Okay, so we are moving to question 2. Okay, which of the following assertions are true? Remember that we are going to justify every assertion. Okay, we are going to justify every assertion according to the instructions. Which of the following assertions are true? Now, the first one says that there exists an x. This symbol means there exists an x greater than 0 such that the square root of x is equal to x. Now let's just verify if it is true. What it's saying is that there is a particular value of x that is greater than 0 that is going to make the square root of x to be equal to x. Normally we know that that is true because the square root of 1 is equal to 1. So and 1 is greater than 0. So this assertion is true. But we need to prove it. Yes, we need to prove it. So let's just go with the square root of x is equal to x. Let's try to solve. Okay, so if I square both sides, what I'm going to get is that x will be equal to x squared. Alright, if x is equal to x squared, I can maybe subtract x on both sides. I'll have something like x squared minus x is equal to 0. Okay, and with that, if I factorize x, I'm going to get x into x minus 1 equal to 0. Now since I have that x is greater than 0, it means x cannot be equal to 0, so I'll just have to do x minus 1 equal to 0, and x is going to give me 1. Okay, so definitely this assertion is true. We'll put C beside it because we have seen that there exists an x that is greater than 0 such that the square root of x is equal to x, and that x is actually equal to 1. So it satisfies all the conditions. Now let's go to assertion number 2. There exists an x that is less than 0 such that the exponential of x is less than 0. That assertion is always false. Okay, that assertion is always false because the exponential function, so this man is always false. Yes, it's always false. But now we need to prove it. So we know that x, we start with x is less than 0. Okay, and if x is less than 0, we can take exponential on both sides. We are going to get exponential of x. The exponential function is an increasing function. Okay, so the exponential of x will be less than the exponential of 0. Okay, which means that the exponential of x will be less than 1. But the exponential function is a positive function, so the exponential of x will be less than 1. Less than 1 does not mean that you are less than 0. Okay, because actually you are a positive function, so you are going to be instead between 0 and 1. So the second assertion is false, which is saying that there will exist an x that is less than 0 that is going to make the exponential of x to be less than 0. So that one is false. So for any value, even if the value is negative, if you take e and you rate it to even a negative number, maybe -1, the result will always be positive. Okay, so there is no value of x that will make the exponential function to be negative. So this assertion is false. Now this man says that this symbol means for every or for all. So for all n in the set of natural numbers, n squared is equal to 19. That assertion is false. Okay, because in fact there is no number that when you square you're going to get 19. And again, for the fact that they are telling us that for every, it means that if you take any natural number and you square it, the result will give you 19, which is false. So for this one, we are going to justify by a counter example. Okay, so you are just going to maybe take n to be equal to 1 because 1 is a natural number. Now if you do 1 squared is equal to 1. You can take any natural number of your choice, but I'm just choosing 1. And 1 squared is 1, but it is not equal to 19, which makes this assertion to be false. That is proved by counter example. Now here it says that there exists a z that belongs to the set of complex numbers such that z squared is equal to -4. That is very true. Okay, because that z will just be equal to 2i if you square 2i. And remember the question, the statement says there exists, which means that there is a particular value of z that will make z squared to be -4. There's a particular complex number that when you square it you get -4. If it's set for all, then it's going to be wrong. Okay, because I will just take any complex number of my choice and square, and once the answer does not give me -4, it's going to make the whole statement to be false. But because they have used the symbol for there exists, it means that actually it is true for some values, not for all values, because of the word there exists. But let us, so this man is true, okay, but let's try to justify it. We can, if we take z to be equal to 2i, okay, then, or even -2i, or we can just solve this equation z squared equal to -4 and get the values of z. So z squared equal to -4. Okay, what does this mean? This means that we are going to take square root on both sides, and we are going to get z to be equal to plus or minus the square root of -4, which is the same as the square root of -1 times the square root of 4. Okay, so you see that we are having two values of z. The first value of z is -2i. Okay, because we know that the square root of -1 is I, and the square root of 4 is 2, and then the other value now is now +2i. Are we seeing that there exists at least a complex number whose square will give us -4? Okay, now if they use a symbol this, that is, and then with a factorial sign, it is read as there exists a unique, which means that it is going to be only one value of z. But when they say there exists, it means that even though there are many values of z, they exist, but we are certain that it is not for all values of z. You see, so this other one is true. So that is it for our second video. So stay tuned for the third video.